Okay, so this is a short video just to introduce the module of polynomials called Poly, which is used in Lab 4A. So this module, all you need to know about it is the following functions together with the instances that Poly enjoys. So Poly is a data type for representing polynomials. What's a polynomial? Well, something like x squared plus 7 is an example of a polynomial. That's a quadratic. So it's powers of x multiplied by various constants. So we'll see that much more clearly when we look at some examples. So this Poly is what's called an abstract data type. What that means is that the module doesn't export any constructors of this data type. So we don't know when we use it how it's represented. Of course, you can look in the file, there's no secret, but you don't have access to that when you import the module Poly. So what that means in practice is that the only way you have of building polynomials are using the functions provided by the module. And in particular, the only function that actually ends up with a polynomial is this one called fromList. It converts a list of ints into a polynomial. So I've imported the polynomial module here, and I've given a few definitions of polynomials, which I've created using fromList. Now, the poly type is a member of show, so I can print these things out so we can see what they look like. So what is a 1, 0 when I convert it into a polynomial? Well, let's have a look. It's just x. So that means that this position represents the first power of x, and this is the 0th power of x. Maybe the second example, ex2, will clarify things a little bit further. So ex2 has a 1 in the first place, 0, then 1. So this means 1 times x squared plus 0 times x plus 1, which is x squared plus 1. So now if you look at this example, you should be able to guess what this will give you, namely an x cubed, no x squareds, no x's, and a minus 1. So let's try that out, ex3. And indeed, it prints out nicely as x cubed minus 1. Now this way of printing it out is nice up to about the power of 9, because there's a character for the superscript up to about the power of 9. Once you get beyond the power of 9, then things start to get messy. For example, if we do from list 10, 0, sorry, that'll be something like 10, 0, 0. No, what am I thinking of? I need a list of length 10. Let's take a list of length 10, 1 up to 10. So they're all looking nice. If I make that 1 longer, then you see that that's what I'm looking for. Once we get beyond 9, we haven't got a nice way of printing them out. But this is just to print them on the screen to make them look nice. It doesn't have any other function. So we can see what we're manipulating. Okay, so what else can you do with a polynomial? Well, if we look at, for example, ex2, which was x squared plus 1, we can evaluate this polynomial by providing a value for the missing bit x, the parameter x, of the polynomial. So, for example, if we were to supply the value 2 for x, we'd expect to get the answer 5, and the eval poly function is the function that will do that for us. So eval poly 2 will give us 5. Okay, what else is there? Well, we can take a given polynomial and, of course, convert it the other way, and that's the toList function. We want to inspect a polynomial. This is the way we do it. We convert it into a list. So, when we convert one of the polynomials like ex3 into a list, then this is the list we get. What else do we have? Well, we've seen that it's in the class show. It's also in the class EQ. We can test whether polynomials are equal. And that's because polynomials is a sort of standard way of writing a polynomial. So it makes it easy to check whether two polynomials are equal. It would be difficult with general arithmetic expressions with all kinds of operators, but not in the case if we restrict it to polynomials. we're also an instance of num. What does that mean? Well, it means that a poly is a kind of number. And what does that mean? What can you do with numbers? Well, you can do all the usual things you can with numbers. For example, you can add them together. So if we take ex2, which is that guy, and ex3, which is that guy, we can add ex2 and ex3 because they are now also a type of number. And what you get is, you see, let me just expand the window a little bit. The ones cancel out here and you just get x cubed plus x squared when we add those two polynomials together. So that means all the operators for numbers will now work on polynomials. Perhaps interestingly, if we take, let's take ex2, another operation that works on numbers are the literals. So the number 1 can pretend to be any kind of number you like. So it can also pretend to be a polynomial. And in fact, of course, there are polynomials which are just constants, and that works perfectly fine. And I think that's just about everything you need to know. Oh, there's one more thing. It's also an instance of class arbitrary. So that means we can, for example, sample arbitrary at type generator for polynomials. Oh, it's not going to work because I'm not in. I need to import. Test quick check to do that. Let me try that again. So we can generate arbitrary polynomials. So there's a bunch of examples. So that means we can test properties involving polynomials.